Hello viewers, in this lesson we will be discussing about Bayes' theorem of probability, which is also a very important aspect of probability. In the last lesson we were able to discuss about the total probability theorem, which we will be applying in Bayes' theorem. So if you are yet to watch those videos, make sure you kindly visit them. So without wasting much of our time, let's move into what we have in this lesson. Bayes' theorem. Bayes' theorem. So what does Bayes' theorem says? Bayes' theorem says if A1, A2, A3 up to AI is a portion of a sample space S, and B is any other event in that same sample space, in the sample space. The conditional probability of AI given B is definitely the probability of AI intersection B over the summation from I equals 1 up to n of the probability of AI multiplied by the probability of B given AI, by the probability of B given AI. So this solution is just to combine or to group everything together. Instead of writing for A1, A2, A3 up to whatever point. So we just try to group everything together with the summation sign. And if you look at this very well, this is quite similar to our concept of total probability. So basically everything you're using to divide the numerator is your total probability. That is the total probability of B, the total probability of B. So what this is trying to tell you is that the conditional probability of a particular event given total probability is equals to that event intersection the total probability over the total probability So let's say our I is up to 3. If n is 3, that is 1, 2, 3. So automatically our probability of let's say A1 given B will be equals to the probability of A1 intersection B over the total probability. So let's break this down. It will now become, we are doing it up to n equals 3. So we start from 1, that is A1. So we have the probability of A1 times the probability of B given A1 plus, remember summation means plus we have done for 1, we move to 2, probability of A2 multiplied by the probability of B given A2 plus the probability of A3 multiplied by the probability of B given A3. So I'm doing it up to 3 because given n, I just assume given n to what? To 3. So same thing applies to the conditional probability of A2. That's the work of Bayes' theorem to determine conditional probability. So anytime you are applying Bayes' theorem conditional probability and total probability are the two things involved. So, and mind you, for A1, A2, A3, you are dividing with the same denominator. You are dividing with the same denominator, which is the total probability. So, for this, we have what? The probability of A2 intersection B over the probability, everything here, you write it here as well, multiplied by the probability of B given A1 plus the probability of A2 multiplied by the probability of B given A2 plus the probability of A3 multiplied by the probability of B given A3. Same thing for the probability of A3 given B. So you also have the probability of A3 intersection B over everything there. I don't need to write that again. And mind you, from your idea of conditional probability, you can break this intersection down into conditional probability and a probability. You can say this is the same as, okay, let me rewrite it. The conditional probability of A1 given B, or let's say the conditional probability of B. Let's put it out. The conditional probability of B given A1. If you want to write it in the form of conditional probability, you can write it as what? As probability of A1 intersection B. Normally it should be B intersection A1, but it's the same thing. B intersection A1 and A1 intersection B are the same thing. Over the probability of A1. Over the probability of A1. So making this sort of formula, you can simply say probability of A1 intersection B is equal to what? Probability of A1 times the probability of B given A1. So you can substitute this for this. So we can definitely say this equals the probability of A1 multiplied by the probability of B given A1. Same thing applies to this. So this will definitely be the probability of A2 multiplied by the probability of B given A2. So that's that with our by experiment. So now let's apply that in an example. Example 1. So the first example we are having here on Bayes theorem, the example says, at a factory, 30% of the instruments are assembled by female specialists and 70% by male specialists. So let's represent female specialists. Let's represent it by F. Let's represent female specialists by F. So we can say probability, let female assemblers or specialists equals F. So the probability that that percentage is same as probability, because percentage is definitely divided by 100. So we just convert that to fraction or decimal. So here we have what? The probability of female, that is the probability that is assembled by female, is equal to what? We are giving us 30%. 30% divided by 100. That's definitely 0.3. So similarly, let male assemblers equals N. So the probability that it is assembled by male equals to what? We're giving to what? 70%. So that's 4.7. Full stop. The reliability of an instrument assembled by the former in this situation is what? Is female, because female was mentioned before male. So if they said later, that would be male, but if they said former, that's the first person. So it says the reliability of an instrument assembled by the former is 0.09 and the reliability of an instrument assembled by the later is 0.8. We are talking about reliability. We are definitely talking about probability as well. That is the chance of being reliable. So it now says an instrument is picked off the shelf at random. Find the probability that it is reliable. That is definitely total probability. So the probability that we are given, the reliability of an instrument assembled by a female, that's a conditional probability. That one is a conditional probability, and the second one is also a conditional probability. So what that one is trying to tell us is that, so it says the reliability. What it's trying to tell us is that the probability that of being reliable, and it is given that it is assembled by a female, that is the former, is 0.09. Is 0.09. So definitely the probability of being reliable. Let's reliable because so the probability that it is reliable, the probability that it is reliable, given that it is assembled by female, by former, is that is given F is equals to what? 0.09 is equals to 0.9, it's 0.9 is equals to 0.9, and the probability, that is the reliability of the instrument assembled by the later is 0.8. That is the probability that is reliable given that it is assembled by male is what? Is 0.8. That is the probability of reliable given male equals to what? Equals to 0.8. So the question answers A, find the probability that is reliable. A, find the probability that it is reliable. We are not given all this information in the question. We are the one that interpreted everything, though we are giving those values, but we don't know what each represents. You are the one, it is your work to interpret those things before you can start solving your question. So B says, suppose that the instrument is picked off the self reliable, determine the possibility that it was assembled by a female specialist, and also determine the probability that it was assembled by a male specialist. What the second question is trying to tell us is that the instrument has been picked and it was found out that the instrument is reliable. It now says determine the probability that the fact that it is reliable, was it assembled by the female or the male? That is, when it is assembled by, if it is assembled by the male, find the probability that it was assembled by the male, and find the probability that it was assembled by the female, but it has been determined as a reliable instrument. So find the possibility that, okay, I've stated that question. Let's begin to solve it first. Writing it down at the end. This value. So the question says, the first one, it says find the probability that it is reliable. That's total probability. P of R. You can determine your total probability from your total probability theorem. Which is equals to the probability. That will definitely be the probability of male, or let's start with female. Probability of female multiplied by the probability of relying given female. Remember, from the concept of total probability, plus probability of male multiplied by the probability of reliable given male. Here we are only having two events, from the formula we wrote it up to 3, but here we are having 2 only. So you can have 5, you can have 7, so the number doesn't matter. So let's and we already have the probability, conditional probability of being reliable for female, and we also have that for male as well from the question. So then maybe this will become 0.3. We also have the probability of female times the probability of reliable given female 4 times 4.9 plus probability of male, that's 0.7, given a probability of reliable given male, that's 0.8. So the total probability will sum up to what? If we do that very well, we should be having 0.8. We should be having 0.83. 0.83. You can check that with your calculator. Find that 0.83. That will be our total probability, and that's the answer to the first question. This is A, this is B. So like the big question that I stated, it says the instrument that was selected is a reliable instrument. So we now want to know the probability that that reliable instrument was assembled by male, and it also said we should determine the probability that reliable instrument was assembled by male specialist. So that's definitely a conditional probability. A conditional probability, that is the probability that it was assembled by a male, given that it is reliable, because the instrument is already reliable. I already stated under the lecture of under the lesson of conditional probability that conditional probability deals with the situation whereby one event has already occurred. So we now want to determine the probability of another event, given that the first event has already occurred. So the instrument is already reliable. We now want to determine the probability that it was assembled by the first situation, that is, was assembled by a female specialist. I determine the probability that a reliable instrument was assembled by a female specialist. So the second one, same thing, assembled by a male specialist. So to determine that's definitely a conditional probability. So for the first one, for I, that will be the probability that it was assembled by a female, given that it is what? It is reliable. So that's where Bayes' theorem comes in. So that's definitely what? The probability of female intersection, total probability, dimension R, over total probability, over P of R. We would have written everything here to the numerator, but since we have already determined P of R, so we don't need to be writing this because it's going to waste our time. So let's just do that. But we don't have the probability of female intersection R. We don't have it, but we can determine it from our concept of conditional probability. We can determine that from our knowledge of conditional probability. So we all know that. So recall conditional probability as probability of R given female. We already have this. That's why we want to use it. It will get our advantage. We already have it as 0.9 to be equal to what? From our conditional probability of female intersection R. R intersection female and female intersection R are the same thing. Over the probability of female. We already have probability of female as well. So making this inside the formula, what do we have? Probability of female intersection R will definitely be what? The probability of female times the probability of R given female. So we can now substitute everything here into this formula. So we can substitute everything into that formula. So automatically, the conditional probability of female, given that the instrument is reliable, will now be equal to what? Will be equal to probability of female. So we want to substitute everything here times the probability of R given female over the total probability, that is probability of R. So what would that give us? Probability of female, we already have it. Probability of female to be what? We already have it in the question to be 0.3 times the probability of reliable given female. That's only what? 0.9. We have it at 0.9 over the total probability which we have calculated. Total probability which we have calculated 0.83. So we do that very well. So we will add 0.325. You can check that with your calculator. So similarly, the probability of male, given that it is already reliable, I just want to determine the probability that it was assembled by a male, given that it is already reliable. So we don't need to go through all this stress again. So I already prove for you guys how we got that formula. So let me just replicate that formula for this one. So I definitely have the probability of male times the probability of reliable given male over the probability of that is the probability. So that's definitely the probability of male will definitely give me 0.7. I've been giving me a question times the probability of reliable given male. Probability of reliable given male, we are beginning as well in the question is 0.8. We are beginning at 0.8. Over the probability, which is 0.83. So if you do this very well with our calculator, we should be getting 0.625. So that's the solution to that problem. So moving to the next example on bias theorem. We'll be solving one more example on bias theorem before we wrap it up. Example 2. Example says a shop is supplied with goods manufactured by 3 factories whose relative quantities are 41 equals to 50%, 42 30%, and 43 20%. So it says 41 is supplied with what? With 50%. 42 is supplied with what? With 30%. 43 is supplied with 20% of goods. 20% of goods. So these are quantities supplied. Quantity supplied. And it says the percentage of defective goods manufactured by this company are 2%, 3%, and 5% respectively. That time telling that the percentage of defective goods for factory 1 equals to 2%, for factory 2, since they use the word respectively, so factory 1, factory 2, factory 3, 3%, and factory 3, 5%. 5%. So the question now says, what is the probability that an article purchased at random will be a non-defective item? How do we go about this problem? We can determine the probability that that item is a defective item. So for that item not to be a defective item, we can apply our idea of complement. That is, the probability that it is not defective will be equal to 1 minus the probability of it is defective. And to determine the probability that it is defective, that's definitely the total probability. So we use the formula for total probability. So we solve this solution. So we can let factory 1, the probability of quantity supplied of factory 1, let's represent it as A. So we can say this is 50% the percentage, that's 1.5. So we can let this one be B and let this one be C. We can say the probability that is supplied by factory 2 to be B, and that equals to what? 0.3. Probability that is supplied by factory 3, let's make it C, and that's 0.2. So probability that it is a defective good, that's a conditional probability. That's a conditional probability. That means the probability that it is defective given it is coming from factory 1, probability that it is defective given it is coming from factory 2, probability that it is defective given it is coming from factory 3. So this should definitely be probability of defective given A, and that equals to 2 divided by 100, and that's 0.02. And likewise, similarly, this will be what? Probability of defective given B, and that's what? 0.03. Probability of defective given C, and that's what? 0.05. So to determine our total probability, so total probability of D, remember our formula for total probability, that's definitely the probability of A times the total probability given A plus the probability of B times the probability of D given B plus the probability of C times the probability of D given C times the probability of D given C. We know the probability of it, which is here already, and we already know our conditional probabilities. So we can apply our formula. Probability of A, which is 0.5, times probability of D given A, that's 0.02, plus probability of B, which is 0.3, times probability of D given B, that's 0.03, plus probability of C, and that's 0.2, times probability of D given C, that's 0.05. So if you sum this together, calculator is getting 0.029. But mind you, we are not trying to determine the probability that that item is defective. We want to determine the probability that that item is not defective. So the probability that the item is not defective, will definitely be probability of D prime, which is equals to 1 minus probability of D. Since D is the probability that it is defective, then the probability that it is most defective will be the complement. And according to one of our theorems, is it from I think that's the two you can to you should be able to whatever the theorem is, you should remember from there, which is definitely equals to 1 minus 0.029. So I'm going to do that very well. You should be having 0.971 as the final answer to that. So that example will bring us to the end of this particular lesson. So if you are new to this channel, make sure you visit the previous videos, and make sure you subscribe, you like and share the video to those that are going to find it helpful. In the next class, we are going to be moving to some other aspects of probability. Thank you.